Okay, here we go. So think about my list of derivatives. Uh, Derivative of a constant, derivative of y equals mx plus b, a derivative of x to the n, derivative of sine and cosine, derivative of trigs, derivative, etc., chain rule, right? We got a long list, probably 12 or so items on it. We're going to have a list of about 12 items for antiderivatives as well, because we have to be able to undo everything, right? So, for example, if I say to you that y prime is 1 over 2 square roots of x, you know that y must have been what? What did I take the derivative of to get there? Yep. So the very first thing we're doing in antiderivatives is saying, hey, recognize your derivative. What did you take the derivative of? Right? If I said to you that y prime is cos of x, what is the antiderivative? Yeah, sine. Right? Antiderivative. So y equals sine of x. So the very first thing you're looking for is, do I recognize it? Right? Do I recognize it? That's it. That's simple. Do I recognize it? And it's that simple. The second thing, so level 1, right? This is my antiderivative checklist. Level 1 is you know y prime, right? From practice, right? So we said that if y prime is 1 over 2 square roots of x, the antiderivative is y equals square root of x. If y prime was cos of x, the antiderivative is y equals sine x. By the way, my wheel for antiderivatives goes the other way. So notice as I move from cosine to sine, I don't pass the negative, right? But what if I said to you y prime was sine of x? What's the antiderivative? Negative cos x. Yeah, so when I gave you this wheel for derivatives, we went this way, right? So if y is cos x, y prime is negative sine x. Now antiderivatives goes the other direction. So meaning for derivatives, if I go from cosine to sine, I pass the negative, right? So that's why I get the negative. But when I'm doing antiderivatives, if I go from sine to cos, do I pass the negative? Oh, sorry, I'll go this way. When I go from sine to cos, do I pass the negative? Yes, that's why I do the negative. So this is my antiderivative direction, right? And this is my derivatives. The second thing on my list is the power rule. So if I say that y prime is x to the n, I'm going to get an antiderivative of y equals x to the n plus 1 over n plus 1. So notice what I did. What did I do to my exponent? Add 1 to the exponent. And then divide by the new exponent. What's nice about all of these is I can check them by doing what? Taking the derivative of the answer, right? So, for example, if y prime, if I already know my derivative is 5x to the fourth, and I'm going to get the antiderivative, right? I'm going to take my exponent and add 1 to it, and then divide by that new exponent. And then I can check, so if y equals x to the fifth, what is y prime? 5x to the fourth. You see how easy this is? This is very, very easy. Step 3 is tricky. Okay, but this is basically the last step, and that would be long division, add 0, or multiply by 1. Long division, add 0, multiply by 1, divide and conquer. So for example, if I tell you my derivative is x squared over x squared plus 1, this one, so divide and conquer is when you have a multi-term numerator, right? This one could be either long division or add 0. I'll do it both ways. So whenever your numerator has the highest degree as the same as the denominator, numerator same or higher, you want to long divide. Okay? So I'm going to long divide here. Sorry, x squared plus 1 into x squared, right? So you ask yourself, what number times x squared will get me x squared? What number? 1. And then come back and multiply, right? Come back and multiply. So 1 times x squared and 1 times 1. X squared plus 1. And then I change signs and add. So I get 0 minus 1. So if y prime is x squared over x squared plus 1, that's the same as 1 plus negative 1 over x squared plus 1. So what's my antiderivative? What's the antiderivative of 1? What did I take the derivative? What? Nice. So y is x minus what? Anybody recognize this one? Arctan. Nice. So wait on most of these for me, okay? But let's take a look at a couple in the textbook. See, this is better, right? This is better than the first derivative test? Hell yeah, right? No? Okay, here we go. So antiderivatives. What problems do I like here? I like everything from 1 to 35. Of course, odds, because that's what you have the answers to, right? Let's take a look at a couple here. Anything look interesting to you in 1 through 15? Can you see it? That might help too, right? if you can see it. Number 9, I like that. You know the Beatles at all? Good, let's do 9 and 11. So I've got y prime. They're giving me a y prime. Or they're not. They're just saying, hey, find the antiderivative, right? But y prime is 10 over x to the 9th. How can I rewrite that? 10 times what? X to the negative 9. So it's a power rule. So my antiderivative y, oh, I screwed up already, sorry, is 10 times x to the minus 9. I'm going to add 1 to the power, divide by the new power. So I have 10 times x to the negative 8 over negative 8. And then I forgot to tell you plus c, plus a constant c. I'll explain that in a second. So I got negative 5/4, 5 over 4x to the 8th, all plus c. So plus c, let me explain this. So the power rule part, okay, Mike? Once you see this, right? Once you see that it's a power rule, once you see that it's x to a power, right? Once you see that it's x to a power, you're taking power, right? Except for one case. So 10 times x to 9, you got an x to a power, you're taking power, right? Now, what does this plus c mean? Well, remember, what are we doing with our antiderivative to check it? We're going to take the derivative. When I take the derivative of this, I get back to 10 over x to the 9. And what's the derivative of the constant? 0. So I need that constant of integration because I don't know if I zeroed anything out when I was taking the derivative. You always assume you did. But the constant might be 0, right? Let's look at 11. Every antiderivative, every single antiderivative. You don't know, but we'll be able to figure it out later. That's right. Let's do 11. That's right. So y prime, this is number 11. Y prime is u to the 4th. I'm sorry, I'll use x's. X to the 4th plus 3 square roots of x over x squared. This is a divide and conquer. When you see a multi-term numerator, you can probably divide and conquer. This gives me x to the 4th over x squared plus 3 square root of x over x squared, which is what? X squared over plus 3 times x to the what? Negative 3/2. Good. What's the matter? You okay? Yep. Good. That's y prime. What's y? What happens to the x squared? Nope, that's a derivative. I'm doing antiderivatives. It's a power rule, so I'm going to add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, and add a constant c. So I get x cubed over 3 minus 6 over square root of x plus c. Make sure you agree with me there. Yep. And how can you check it? Well, you can look in the back of the book, or you can take the derivative, right? On the test or quiz, you're going to take the derivative, right? What's that? Doesn't matter. Yeah. Say it again? Yes. Yes, eventually we're going to, instead of saying antiderivative, we're going to say the integral. No, this is chapter 4. This is not on the test on Thursday. If you're not ready for the test, don't start the new material. Start the new material over the weekend after the test or after we come back Monday, okay? Let's do a weird one. If y prime is 1 over x, what is y? Almost ln of the absolute value of x. So this is a weird one, okay? Plus c. Whenever we're taking an antiderivative, we're adding that constant of integration, that constant that could have been killed by the derivative, right? Question. This one is not a power rule. It's not a power rule because this is an x to the minus 1. And if I take my x to the minus 1 and add 1 and then divide by the new, I'm in trouble, right? So not a power rule. Y is the absolute value there. If I start with y equals ln of x, notice I'm not using the negatives, right? So my derivative just comes from 1 over x for x greater than 0. But if I start with 1 over x, I have both the positive values and the negative values. So when I get my antiderivative, I need to be careful about plugging a negative into ln, and the way I can kill it is by making it an absolute value. I'll finish this. I'll do some more of this tomorrow. Have a great day. Math Learning Center is opening up if you want to go work there. Anybody doing